Hello everyone, my name is Dr. Andrew Hewitt and I am a lecturer in textiles at the University of Huddersfield and a bit of a nonwovens geek. In this short video I'm going to take you through a journey through the wonderful world of nonwovens. So, first things first, what exactly are nonwovens? Well, nonwovens are a type of textile which differ fundamentally from the woven and knitted textiles that you may be more familiar with. Whereas woven and knitted textiles are constructed from yarns, which in turn are constructed from filaments or fibres, nonwovens typically do not contain yarns and the basic building blocks are filaments and fibres. Therefore, when you're making a nonwoven fabric, you don't have to go through all the production steps to convert fibres into yarn and then weave or knit the yarns into fabric. Instead, it's a much simplified process, producing a web of fibres which are then bonded together to form a fabric. So, cutting out all the steps often means that nonwovens are quicker and cheaper to produce than more traditional woven and knitted fabrics, but nonwovens don't just exist because of their possibility of being cheaper and quicker. So, nonwovens can be made out of exactly the same types of fibres and polymers as woven and knitted textiles, from what we call staple fibres, which are fibres with a set length, a certain length, or filaments, which are effectively continuous. So nonwovens can be made from the likes of polyester, cotton, wool, polypropylene, viscose, nylon, acrylic, hemp, jute, to name just a few. As well as that, they can also be made of materials that you couldn't possibly make traditional textiles out of. You could even make a nonwoven out of the gunk out of your vacuum cleaner, you know, the dust and the short fibre, which you could empty out, though I'm not sure what you'd use that fibre for. Because there are so many ways to make nonwovens, I'm going to whiz through them. My nonwovens lectures are usually about 4 hours and not just a couple of minutes. But one consistent is there are two main steps to making nonwoven fabrics, which are web formation, which is forming a web of fibres or filaments, and web bonding, which is bonding the fibres or filaments together. There are numerous and different ways of forming webs, and there are numerous different ways of bonding them, so this combined with all the variables within these different ways ends up with there being oodles of different variables and therefore oodles of different types of nonwoven, from lofty, full of air insulation products to immensely strong and durable geotextiles to nanofibrous membranes to filter viruses, for example. So I'm going to whiz through a few examples of web forming and bonding, so hopefully you can have an idea of the range of nonwovens out there. So, very briefly, carding. Carding is a technique where you effectively comb your fibres, separate them out to form a web. It works in the same way as brushing your hair or combing your hair does, but it's using big rollers with pins on them. Orientates the fibres in one direction predominantly, just like brushing your hair does. Airlaid, you blow your fibres into air and let them settle down because they land relatively randomly. They're not oriented in a certain direction like carded fibres are, and therefore the resulting fabrics have very different properties. Then we have wet laid, and wet laid essentially is very, very similar to making paper. You suspend lots of short fibres in some water, drop it down onto a mesh screen, and then you produce a web of fibres, and that's known as wet laid. Then you have melt spun, solvent spun, and wet spun. The melt spun, you take thermoplastic fibres, which are basically polymers that melt, squeeze them out of the little dies, very, very small, put them into jets of air. They stretch out to become very fine fibres, and they can be deposited onto a belt. There's all sorts of subsections of those, so which break the fibres up. Some use hot air jets, some use cold air jets. But that technology is very popular, particularly for fabrics known as spun bond and melt blown, which are the type of fabrics found inside of a COVID mask, a disposable COVID mask, for example. Solvent spun or wet spun, you dissolve your polymer, whatever you're going to make your fibre out of, in a solvent, and then extrude it out, and then that solvent's displaced. In solvent spun case, by air, evaporates away. Wet spun, it's displaced by another liquid, and it precipitates out into that liquid, and they can be collected in a belt or a drum or something to form a web. So in terms of bonding, a couple of examples here as well. Mechanical bonding, where you basically twist fibres together through mechanical action. Needle punching with barbed needles is one way of doing it. Hydroentanglement with little water needles, effectively, little high pressure jets of water to twist and the fibres around each other, is a popular technique known in America as spun lace. Thermal bonding, so by heating up, either passing your web through between heated rollers which push it together, melt something that's meltable in there and basically bonds the web together. So you need at least some meltable fibres in a web if thermal bonding is going to be of particular use to you. Don't have to be all, but some of them do to help glue it together. Or you could blow hot air through, or just pass it through a normal conventional oven just to bond those together and give a bit of strength. And then chemical bonding, very much like gluing. You're basically putting a chemical binder in there which basically glues the fibres together, and then that's usually dried off, heated off, and it sticks together. It can change the feel of the fabric quite a bit, but it can give some very strong non-woven fabrics. Now, I'm not saying non-wovens have exactly the same properties as woven and knitted fabrics. They have different properties, but they have some advantages and some great creative advantages. They don't fray, for example, because they're not made out of yarns. So you can cut out non-wovens to make these fantastic shapes like the petals or butterflies on the right, or the discs on the left. No fraying, gives all sorts of creative possibilities. And there's lots of other properties they have as well, unique properties. And if you're looking at doing something creative with textiles, non-wovens as a family or a group of materials is certainly worth checking out to see what creative possibilities they are. Okay, well that's pretty much all the time we've got. I hope you enjoyed this whistle-stop tour of the wonderful world of non-wovens, and that I've opened your eyes to these fantastic materials a little bit, and you'll maybe consider them in the future. Thanks very much for watching. I hope you enjoyed. Take care. Bye for now.